examples as you need, right? And then you can try the homework worksheet that I post. Okay. Okay. E. Okay. At this point, let's see what we have for my next one. Okay. Now we have a limit, an ln. Okay, so we had this. Okay. So I plug in infinity, I get ln of infinity over infinity, 2 times infinity, so that's infinity over infinity. Okay, L'Hopital's applies. So I take the derivative of the top and the bottom. Derivative of ln of x is 1 over x. Derivative of 2x is 2. Okay. Before you go in and evaluate this limit, right, simplify this. Right, this is the same as, well, this is the same as 1 over 2x. Right? Okay, that looks like it's ready to evaluate the limit, so I'm just going to, remember, you need to, when you're about to evaluate the limit, you need to write limit as x approaches infinity in front. Sorry, document camera is not quite cooperating today. I plug in infinity, it's going to be 1 over infinity. Hey, that's 0, or approaching 0. Okay, there we have my limit. Okay, next example. And if you're following, if you're still watching the examples at this point, this should be a great time to use that pause button, right, to help you out. Okay. Okay. Oh, sorry, we're not doing this example. Sorry. Okay. Not doing that one. That's for a different, right, that's when I've done it in different classes. Okay. Let's see, next one here. And I'm just trying to make sure I get the ones that we're actually going to do. The limit as x approaches 0 of tangent of x over x squared minus 1. Tangent of 0 is 0 over negative 1. Answer 0. No need to do any L'Hopital's there. Okay, so remember, don't do L'Hopital's unless you have to do L'Hopital's. Okay. 0, 0, therefore L'Hopital's applies. Okay. The derivative of that, the derivative of the numerator is secant squared. Derivative of the denominator is 2x minus 1. If I plug in 0. Now maybe you don't know secant, but you do know cosine, right? Cosine of 0 is 1. Secant is the reciprocal of cosine, so it's still 1, and squared is 1. Okay, great. Now we don't need to do our derivatives again, we know that. Plug it in here, got negative 1. Okay, there's my limit. So I feel like what we're able to do now is we're able to evaluate a lot of these limits that we couldn't do before. Right? They just were kind of unattainable before. Okay, so let's take a look at the next example here. All right, and let's see. Let's say we have something like this. Okay. Now some people say, does it always have to approach 0 or 1? And this is a great example of when it doesn't have to. Right now we're going to approach in 1. If I plug this in, right, for myself, right, ln of 1 is 0. 1 minus 1 is 0. Okay, L'Hopital's applies. Okay. So L'Hopital's applies. I can then take my derivative of the top and the bottom. Derivative of ln is 1 over x. This is 1. When I simplify this, this is just let's see, let me write this out. 1 over x. If I plug into 1, my limit is 1. Okay? So that one's pretty straightforward and clear. Okay. Now, if you think back to what we did before, right, here's an example where you could use L'Hopital's, but you really don't have to if you don't want to. Okay. You may or may not remember that from the beginning of the year, right, we did a problem like this, and you could evaluate this limit. Okay. And if I just said, oh, let me plug it in and see if what I get infinity over infinity, so it says L'Hopital's applies. But it's still good, even though we have L'Hopital's, doesn't mean we want to use it in all cases, right? So for this one here, right, keep in mind the fact that since we're approaching infinity, right, when you're approaching infinity, and if it's polynomials, just look at which one, what each one's approaching, and I look at it and I say, oh, okay, this is approaching infinity, so this one's what really matters, and this one's what really matters, and x cubed divided by x squared is x. Oh, so this is going to be infinity. So I didn't use L'Hopital's for this, even though I could have. L'Hopital's would have been a whole lot more work. So I don't want you to think that you have to use L'Hopital's every single time. Okay? So those are some examples for me. Right now, go try the problems I'm going to assign for homework that are going to be attached. Right? Use the notes to help you to do these. Right? And you should be just fine. Right? Good luck.